every little once in a while. Don't you hear me calling? Don't you hear me now? Don't you hear me calling? Every little once in a while. Don't you see me coming? Don't you see me now? Don't you see me coming?
Now this is going to be a spherical question, so I'll write that at the top here. So we'll be dealing with spherical coordinates, okay? So sometimes these can be a monster, but I'll show you that just as long as you approach it in a systematic way and follow all the rules and do things like we're supposed to, then we'll get to the right answer. Don't worry. So let's look at the problem. We have calculate the triple integral, so triple integral over w using spherical coordinates. So using spherical coordinates. Okay, so we're given f of x comma y comma z equals the following, which is y, and our w, so this is the important part here. Not that f of x, y, z isn't important, but anyways, this is the crucial part. W is x squared plus y squared plus z squared is less than or equal to 1. And x, y, z is less than or equal to 0. So what this means, this notation just means the same thing as x is less than or equal to 0, y is less than or equal to 0, and z is less than or equal to 0. So this is basically laziness, a short way of writing all this out. Anyways, so let's, like on the last example, I like to draw things. So let's draw this out and see what it looks like. So we have our x, our y, and our z axes. And I'm going to attempt to draw some kind of spherical object. Okay, it looks a little bit hairy, but anyways, it's a fuzzy sphere. Okay, so pretend this is a sphere, and we have it going around, and it's centered at 0, and the radius is going to be 1. Okay, so another connection, I don't believe I made it in the concepts video, but x squared plus y squared plus z squared is equal to rho squared. Okay, so that's an important connection to make there. Alright, so anyways, all of these, when it goes to the x-axis, the y-axis, and the z-axis, that's going to be 1. Alright, and this part here, that means that our coordinates are going to all be negative. So that means that, so the axes that I've drawn here, these are all positive. So that means if we extend the x-axis back, this is the negative x-axis. If I extend y down here, that's the negative y-axis. And if I extend z down, that's obviously the negative z-axes. So basically what we're looking at is the little, I guess, eighth of a, well, it's called an octant. We're looking at this one in the very back, the far left one, which I'm trying to highlight back here. It's kind of hard, but it's turned away from us, basically. So it's back there, facing away from us. I don't know if you can see that. But anyways, so that's what it looks like. And now we have to determine the bounds. So, using spherical, so spherical means our rho, phi, and theta, right? So let's use this relation here. So we have this information. It's always useful to start with the given information, right? So we have x squared plus y squared plus z squared less than or equal to 1. So if we use that and the fact that rho squared equals all of this, we can replace the left side with rho squared, less than or equal to 1. So if we square root both sides, square root, we get that rho is less than or equal to 1, and automatically, because it's a radius of some sort, in this case rho is a spherical radius, it has to be greater than or equal to 0. So this is the bounds, these are the bounds on rho, so we have that, so that's good, it's a good start. Now we need to determine phi and theta. Okay, so I'll continue this on the next slide. So again, I'm just going to draw, I'll do like a quick sketch of what we're looking at here. So these are the faint ones are the negative axes, y and z. So I'll refrain from drawing the rest of the sphere, and I'll just draw what we're looking at. So this is kind of behind everything, all right? So this is the octant that's kind of hidden in the back. So basically, what we have is this octant. That's what we're looking at, is our W, okay? So this is actually our W naught, I believe, since we're, well, W naught, because we're using spherical coordinates and not the original XYZ. But anyways, that's just technical terms. So if we're looking at this, we already determined that rho is going from 0 to 1. And now let's look at, let's look at phi. So phi normally goes from 0 to pi. Remember, phi is the angle measured from the top, so measured from top. So the z-axis. So at the z-axis, it's 0, right? And then as we go down, you can either go down this way or go down this way. It's going to end up being the same thing, because remember, we're rotating the entire thing around with our theta. That's what the function of theta is, to rotate around the z-axis. Anyways, so as we go down, see how we're not hitting the region yet, right? So from 0 to pi over 2, our phi is serving no purpose. So that is not included in our interval. So at this point, though, phi equals pi over 2, right? Right here, okay? And you can also consider it right here as well. I'm just doing it here so it actually touches the region. So phi starts at pi over 2. And then let's see, as we continue going down and making our orange slice, remember, paper thin orange slice, and it stops here. Because if we keep going, this is actually just touching air again. Alright, so these are doing nothing, and it stops at phi equals pi. Okay? So it might be a little bit hard to see on the drawing here, and I'm sorry about that, but doing the best I can with a two-dimensional surface here. So anyways, so those are our bounds for phi. And then now the last one is to look at theta. So again, I'll draw a little sketch of what we're looking at here. So we're looking at this one, this piece back there. Okay, so it's hidden from us. Anyways, so it's like that. And so theta, here's our x-axis, positive x-axis, positive y-axis, and z. So theta starts here. So theta equals 0 here, and that's touching nothing, absolutely nothing. So if we're just looking on the xy plane, we're going across, no, it's not hitting the region yet until we get to this point. So at this point, theta equals pi. And then we're going to keep going, right? And yes, we're going through the region, and this is the very last point at which we're touching the region with theta. So this is 3 pi over 2. And then once we exit that and theta becomes bigger and bigger and goes toward 2 pi, then we're going out of it already. So theta is going from pi to 3 pi over 2. And for this last one, I can always you can always sketch it in terms of the x and y plane, because theta only exists on the x and y plane, and the y-axis is very curved, strangely. Hold on, let me try that again. There we go. Okay, so here's our x and y, and here's our sketch of a circle kind of thing. But our octant only looks like this from the top. Okay, so as you can see here, theta is 0 here, no, that's not included in the region until you get here, where theta equals pi. And then the second limit is 3 pi over 2, because that's where you would cross back into not hitting the region at all. Okay, so now we have our bounds, and this is pretty much the most important part of any kind of integral problem. And then you just solve the rest mechanically. But that's the part that I think takes the most conscious thought. So, alright, so then another important thing to note is that f of what used to be x, y, and z equaling y, now once you plug in our rho, phi, and theta, y in terms of those is rho sine theta sine phi, right? So anyways, now that we have this here, that's important as well. We'll need that for our final setup. And we also remember that dv in spherical is rho squared sine phi d rho d phi d theta. Okay, so now we have all the tools to put together the complete triple integral. So we're going to start with theta bounds, okay? So we'll start with pi up to 3 pi over 2, and then we'll go with phi bounds, so that'll be pi over 2 to pi, and then we go with rho bounds, so that's 0 to 1, okay? And then I'll plug in our, what used to be y, remember, now it's rho sine theta sine phi, and then we have don't forget the Jacobian, rho squared sine phi, and then our d rho d phi d theta, okay? And always make sure to that these match the bounds with their differential. So these both describe something related to rho, and the second ones describe something related to phi, and the third ones, the outer ones, describe theta, okay? And now we'll just combine. So we have pi up to 3 pi over 2, and then pi over 2 up to pi, and then 0 to 1. And we can combine the rows, and we have like that, rho to the third, and then we have sine theta, is just there, and then we have a sine squared phi, okay? And then we have, of course, our differentials at the end here, bringing up the rear. So at this point, we're again at an iterated integral, so we can break it up into in terms of the variables. So first, I'll actually have the thetas. So we'll go from pi to 3 pi over 2, and we'll put the theta thing. So that's just sine theta, and then d theta. And then next, we'll have the phi stuff. So pi over 2 up to pi, and we'll have sine squared phi. And this is d phi, okay? And the last thing is the rho stuff. So then we'll have rho to the third, d rho. All right, and now we'll just solve through each one separately. So first here we have a negative cosine theta. That's what that turns into. And then as theta goes from pi to, pi to 3 pi over 2 in parentheses. And then we have here, this is actually a bit, well, not complicated, but anyways, I'll just leave that here for now, and I'll explain it more on the next slide where I have room. So I'll leave that like that for now. And then this can turn into a 1 over 4 rho to the fourth, as rho goes from 0 to, not 0, 0 to 1. Okay? All right, let's continue on the next slide. So here I had a negative cosine theta, negative cosine theta, and that went from 3 pi over 2 to pi, okay? So we have that, and these turn positive. Whoop, I was trying to go through there. And then we had this, so this was pi over 2 to pi of sine squared phi d phi. And then over here I had a 1 over 4 rho to the fourth, so that would be 1 to the fourth minus 0. Okay, so this will just be a 1 over 4. Alright, so what this is here, what was important here is that remembering, again, the double angle formulas. And if you aren't familiar with these, I would actually suggest looking over some formulas and studying them just a little bit so that you can recall some formulas like this when it comes in handy, because it often does, especially with trig functions like sines and cosines and things. So basically, this is one of the double angle formulas. So to get sine squared by itself, sorry, I changed variables there. Hold on, let me go back here. Sine squared theta, sure. So to get sine squared by itself, you would add it over there, so then you get 1 minus cosine 2 something over 2. So in this case, we would just replace the thetas with fees. Yeah, so anyways, let's do so for the middle one. So we have, let's see what this turns out to be actually first. So we have a positive cosine pi, so that's a -1, and then this is 0. So we have a -1 in front, and then we have if we replace sine squared phi with 1 minus cosine 2 phi over 2, this is what we would get. I'll just put the 1/2 in front already, so we don't have to deal with it really. Just save us a step. So then the rest in here is 1 minus cosine 2 phi. Okay, so this is the same thing as the parentheses all over 2, but I just moved the 2 in front here. Okay, and then at the end, bringing up the rear, we have a 1 over 4. Okay, so I'm just going to combine all of the coefficients here and make that a -1/8. And then I'll break up the inside here, split it with the minus sign so that we can kind of decompose it and deal with it separately. Minus pi over 2 up to pi, and then a cosine 2 phi d phi. Alright, I have the right number of parentheses. Okay, so now at this point, we can apply the u substitution. So we'll make u be 2 phi. That way du is 2 d phi. And to get d phi by itself, we just divide by 2 on both sides. Okay? Alright, so I'll implement the u substitution on the next one. So we have a -1 over 8 in front still. And then we have a theta going from, oh wait, hold on here. Sorry, I switched variables. Yeah, so this is actually, hold on, back up. This is a phi, sorry. I always like to write thetas for things. I'm so used to them from previous classes. So, going from pi over 2 up to pi, and then minus, and here we're going to implement the u substitution. So we have cosine u, and instead of d phi, we have du over 2. Alright? So then from here, we're just going to continue solving. So we have our -1 over 8 in front, and then a pi minus pi over 2. Okay? And then minus, I'll bring the 1/2 out in front. 1/2, then we have a sine u. Alright? And now on the next one, I'll replace u with the 2 phi that it represents. So then we have 1 over 8, and then here we have a positive pi over 2 minus 1/2 sine 2 phi, as phi goes from pi over 2 up to pi. And now we'll just plug it in and see what we get. So we have pi over 2 sitting in front there, the 1 over 2, then we have a sine 2 pi minus sine 2 times pi over 2 is pi. So these, actually, this whole term here, that turns out to be 0. Because at 2 pi and pi, sine is 0. So our final answer, we still have this in front. So we're going to get negative pi over 16. Okay? And that does it for that question, even though it was pretty long. But this is the correct answer. I have verified it. So, yay. See how it's pretty rewarding to find out at the end that all the work that you've been doing is correct. So, anyways, with more practice, and even if it isn't correct, at least you're working through it and learning from your mistakes and looking back and seeing the correct way to do it. So anyways, I'll talk to you in the next practice problems video.
Every little once in a while, I mean it. Every little once in a while, you better bring a little water, Silver. Bring a little water now. Bring a little water, Silver.